Hello. In this video, I'm starting chapter 7. So I will cover the first part of section 7.1. I'm going to do the first part of linear equations in this video, and I'll do a second video to finish the section. So this video is about algebraic models, and I'm going to copy the first definition. So first, what is a linear equation? I'm going to copy that. This is page 307. A linear equation in two variables is an equation that can be written in the form ax plus by equals c, where a and b are real numbers and b and c are not both zero. When a linear equation is written in this form, it is in standard form. Some examples of linear equations are r minus 3x plus y equals 6 and 5p equals 6q minus 4. So these are examples of linear equations in two variables. And a solution for an equation or let's say, or not necessarily linear, a solution for an equation is a number of numbers such as if we substitute them for the variables in the equation, the resulting statement is true. Okay, so we're going to be working with linear equations into variables and solutions of linear equations into variables are ordered pairs of numbers. For example, the order pairs one, 1, and 3, -2 are solutions of 3x plus 2y equals 5. So if we plug in the numbers, the order pairs are going to be in alphabetical order. They always go in the order xy. So if we plug them in, we have that 3 times 1 plus 2 times 1 is 5. Is indeed 5. And the order pair 3, -2 is also a solution. If we plug in the numbers, 3 times 3 plus 2 times -2, 3 times 3 is 9, 2 times -2 is -4. So we have two order pairs that are solutions of the same linear equation, 3x plus 2y. Two equations are said to be equivalent. if they have the same solutions. Examples of equivalent equations. The equations minus 2x plus y equals 4 and y equals 2x plus 4. These two equations are equivalent. They do have the same solutions. So we have a few rules for rewriting the equations in equivalent form. This is also on page 307. In order to rewrite equations in equivalent form, you can add or subtract the same expression from both sides of an equation to get an equivalent equation. Or you can multiply or divide both sides of an equation by the same non-zero expression to get an equivalent equation. This tells you that. Okay, so you have number one, another way to call it is the addition rule. It says that if A equals B, and C is any real number, then you can add the same number to both sides and things remain equal. So the word equation comes from equal. So adding the same thing to both sides is not going to change the fact that the expressions are equal. And number two says that you can multiply or divide both sides of an equation by the same non-zero expression to get an equivalent equation. This is also called the multiplication rule. It says that if A equals B and C is any non-zero real number, or it can be a real number, then A times C equals B times C. So that's not going to change. Multiplying the same thing to both sides is not going to change the fact that both things are equal. So this has a couple of consequences. So the above rules have two consequences. The first one is that if A equals B and C is any real number, I can call that 3. If A equals B, then A minus C equals B minus C. So you can subtract the same thing from both sides. And there will no need to write that because C is any real number, so it can be a negative number. And 4, you can divide by the same thing, by the same number, as long as the number that you are dividing by, or as long as the divisor is not 0. So if A equals B and C does not equal 0, then A over C equals B over C. So we learn all the stuff about real numbers. You can multiply by the reciprocal of a number, of a non-zero number, and that's equivalent to the multiplication rule. So we use the properties to solve linear equations or to write equations in equivalent form. Okay, so first part, we are going to solve 8x plus 10y equals 40 for y. So what we're going to do is isolate y on one side. So this is our equation. We can subtract. If we're going to isolate y, we are going to isolate first the expression containing y. We can subtract 8x from both sides. And then subtract, and then divide both sides by 10. So we can divide everything by 10. Uh, 10 over 10 is 1. So we have 1 times y, or simply y. Uh, 40 over 10 is 4. And 8 over 10, that simplifies as 4 over 5. Okay, so we solved the equation for y, or we wrote the equation in equivalent form. So 8x plus 10y equals 40 is equivalent to y equals 4 minus 4 over 5x. Both equations will have the same solutions. And P, the equation f equals 9 over 5c plus 32. This equation converts degrees Celsius to degrees Fahrenheit. We are going to solve this equation for C. So this the equation, so F is given in terms of C. We're going to do it the other way. We're going to write C in terms of F. The idea is to write C by itself on one side. So what I'm going to do is switch the sides. If we're going to isolate C on one side, we need to first isolate the expression with C. We can do that by subtracting 32. And next, we can multiply by the reciprocal of 9/5. We can multiply both sides by the reciprocal of 9/5. Okay, so that's the reciprocal. The reciprocal of 9/5 is 5/9. Okay, so C is equal to, there's nothing we can simplify, or we cannot reduce those fractions, so we're just going to leave it as 5/9 times F minus 32. And we can use this formula for to convert temperatures. So suppose that Suppose that we want to convert 86 Fahrenheit degrees to Celsius. So 86 Fahrenheit degrees, or degrees Fahrenheit, 2 degrees Celsius. We can just plug it. We can just plug it into the formula, into the last formula we obtained. So we're going to plug in F equals 86. This is 5/9 times 86 minus 32. 86 minus 32 is 54. But 54 over 9 is 6. And 5 times 6 is 30. So at the end, 86 degrees Fahrenheit is equivalent to 30 degrees Celsius. The next topic is the rectangular coordinate system. So it's called rectangular, or it's also called Cartesian, named after the French philosopher and mathematician René Descartes. Okay, so the way this works is that two perpendicular number lines intersect at a point called the origin. And each point, so let me write this. We have two number lines that are perpendicular. One line is vertical, the other line is horizontal. Once we have that, each point corresponds to an ordered pair, XY. I can actually write this on the side. Each point corresponds to an ordered pair, XY. So usually the horizontal axis is going to represent the set of X values, and the vertical axis will represent the set of Y values. And the point 0, 0 represents the origin. So both lines are going to intersect at 0 of each line. Okay, so they intersect at the point 0, 0, and the point 0, 0 represents the origin, or is called the origin. Okay, so the point 0, 0 is the origin. That's going to be this point here in blue. And we have other points determined by the position on the number lines. Like we can have the point 1, 2. So that point is going to be 1, 2. A point over the x-axis is going to be the point 3, 0. We can have a point like -3, 4. Determined by the position, the x-axis and the y-axis. A few more, where both are negative, are -2, -3. 0, -2. And one more is 4, -3, or 4, -4. So those are examples of points on the coordinate system. We're going to now plot several solutions for the linear equation given below. Okay, the linear equation is 3x minus y equals -1. So what we're going to do is solve this equation for y. I would say the easier way to get solutions is to solve the equation for y and substitute some x values. That way, it's going to be easier to find a set of ordered pairs. Okay, so we can do what? We can add y to both sides. So 3x equals -1 plus y, and we can add 1 to both sides. So 3x plus 1 equals y, or y equals 3x plus 1. So we have y in terms of x. We can just choose any values that we want. If we let x equals 0, y is 3 times 0 plus 1. But 3 times 0 is 0. So the first order pair is going to be 0, 1. If we plug in x equals 1, y is 3 times 1 plus 1. 3 times 1 is 3. 3 plus 1 is 4. So the second order pair is 1, 4. And I'll do 2 more. If x is 2, y is 3 times 2 plus 1. 3 times 2 is 6. Plus 1 is 7. And that's 2, 7. And I'll do one more. X equals -1. Y is 3 times -1 plus 1. 3 times -1 is -3. Plus 1 is -2. And we got what? We got -1, -2. Okay, so we have a few order pairs. We're going to plug them. We're going to plot the order pairs on the coordinate system. So let's do that. Okay, so the x values, we chose them from -1 to 2. Y values, we got them from -2 to 7. Okay, so y values from -2 to -7. And x values, -1, 0, 1, and 2. So if we plot the points, we got what? We got the points 0, 1. We got 1, 4. We got 2, 7. And we got -1, -2. Okay, we connect the dots in this case with a line segment. Yeah, I didn't do very accurately, but yeah, this should be 2,7. And at the end, all points lie on a straight line. That's why this type of equation is a linear equation, because the graph on the coordinate system is going to be a line. So that's the first note. The reason why such an equation is called linear is because the graph of a linear equation is always a straight line. Okay, we can also talk about the intercepts of a line. So I'm going to copy that. Well, actually, we're not going to do, okay, I'll copy this again because we don't need, yeah, this C figure, that's a little bit extra. So let's try again. There it is. On page 309. The x-intercept of the graph of a linear equation is the point where the graph crosses the x-axis. And the y-intercept is the point where the graph crosses the y-axis. So if we're on the coordinate system, and we have the graph of a linear equation, which is a straight line, the point where the graph crosses the y-axis is called the y-intercept. That occurs when x equals 0. You can see the x value is going to be 0, and the point where the line crosses the x-axis is called the x-intercept. That occurs when y is 0. So what we're going to do is find the intercepts and sketch the graph of the following linear equation. find the intercepts, and sketch the graph of the linear equation. The linear equation is 4x plus 5y equals 16. Okay, so usually the intercepts are good points to start. Okay, so if we want to find the x-intercept, we're going to let y be 0. The y-intercept occurs when the y value is 0, and 4 times or 4x plus 5 times 0 is equal to 16. But 5 times 0 is 0. And solving 4x equals 16 for x, divide by 4, and x is 4. So the x-intercept is 4, 0. The y-intercept, to find the y-intercept, we're going to let x be 0. So 4 times 0 plus 5y equals 16. This is 5y. Plus 4 times 0 is 0. So 5y equals 16, or y equals 16 over 5. So the y-intercept is 0, 16 over 5. Okay, so to draw the graph of a line, all we need are 2 points. Now the problem is that one of the intercepts involves a fraction, and those are not the nicest points to graph. So we're going to plot a third point, one that has integers. So it's a little bit easier to graph the function. Let's plot a third point, also known as checkpoint. Plot a third point or checkpoint. So let's write again the equation. The equation was 4x plus 5y equals 16. Okay, so this is what we can do. We can solve for y, or not even for y. Let's just write 5y on the left side. So I'm going to choose an x value. So the y value is a multiple of 5. We can let x be -1. So 5y equals 16 minus 4 times -1. This is what? This is 16 plus 4 equals 20. Divide both sides by 5. And y is 4. So the third point is going to be -1, 4. And we have 3 points. So I'm only going to use 2 points. I'm going to use the x-intercept because it involves integers, and I'm going to use the checkpoint, -1, 4. So we have that the x-intercept is 4, 0, the y-intercept is 0, 16 over 5, and the third point, the checkpoint, is -1, 4. So let's plug it in. Let's plug them in. Okay, for the y values, we got them up to 4. X values, we got also up to 4. Okay, so the checkpoint was -1,4. The y-intercept was 4,0. And if we draw the graph, the y-intercept, which is hard to visualize because it involves fraction, is 0, 16/5. Okay, so I'm going to, in this video, I'm going to do one more example, an application of intercepts. And I will continue with this material next time. But I'm going to go over example 3. Interpret the intercepts. That's on page 310. Suppose that you have saved $2,205 to use for living expenses next semester. Would you expect to be $315 per month? Express this information in an equation using the variables R for remaining cash and M for the number of months you're spending the money. Interpret the meaning of the intercept for this graph of the equation. Okay, so R represents remaining cash. And M is going to be the number of months. This is the number of months you're spending the money. Okay, so if you start with 2205 and spend 315 per month, R is going to be the $2,205 that you start with, and every month you are spending 315. So that's going to be 315 the first month, 315 after 2 months, or 315 times 2 after 2 months, 315 times 3 after 3 months, and so on. That's going to be 315 times M. 1 month is 2,205 minus 315. 2 months is, after 2 months, you subtract 315 to that. After 3 months, you subtract other 250 and so on. That's the equation. We're going to call this the R-intercept. If we want to find the R-intercept, we're going to let M be 0. If we let M be 0, we know that R is 2,205 minus 315 times 0, or 2,205. So that's what we already knew, that initially, that is after 0 months, you have $2,205 remaining. So that's the R-intercept, and the M-intercept To find the m-intercept, let r be 0 and 2,205 minus 315m is 0. So so I'm going to write 0 equals that. That's the way the equation was given. So solve this for m. We can add 315m to both sides. And divide both sides by 315. So m is 2,205 divided by 315. That is equal to 7. This means that after 7 months, you have no money remaining, or you have spent all the cash. After 7 months, you will have spent all the money. If we write the intercepts as points, we have that, we have what? We have that the r-intercept was 0, 2,205. That was the r-intercept. And the m-intercept is 7,0. Okay, so I will continue with this section next time, but I'm going to stop here. Thank you for listening.